We're going to look at quadratic functions, and a quadratic functions in the form f of x equals ax squared plus bx plus c. It's called a quadratic function. Its shape is U. It's not a V, it's a U-shaped. And that U-shape is called a parabola. It has symmetry with respect to a line called the axis of symmetry. And you will also find that vertex on your axis of symmetry. A very nice form, that's the standard form. The quadratic form, I would call this vertex form myself. The axis of symmetry is that x equals h. The point h comma k is your vertex. If a, your leading coefficient is positive, it opens up. If it's negative, it opens down. All of this should be a review from you from Algebra 1, Algebra 2. All right, so in example 1, we're going to state the vertex axis symmetry, the direction it opens, its max, min, and shape compared to the parent graph. So first of all, its vertex, and if you remember, it's f of x equals a times x minus h squared plus k. So your vertex is going to be what? What's the x value of your vertex going to be? It's minus h, this is plus 1, so it's minus 1. And then k, it's plus k, so it's going to be minus 3. Its axis of symmetry is at x equals negative 1. Remember, the vertex falls on that vertical line. What direction does it open? Why? Because the 2 in front is positive. So if it opens up, does it have a maximum or a minimum value? It has a minimum at y equals negative 3. Okay? When we talk about maximum value, I want y equals. Okay? Now, its shape compared to the parent graph. It's going to be skinnier, narrower. I'm going to graph the parent graph here. We know this, starts at 0, up 1 over 1, over 2, up 4. Right there's the parent graph. All right. Now let's graph what we know about this one. We know at x equals negative 1, we have the axis of symmetry. We also know at negative 1, 1, 2, negative 3, we have the vertex. What happens then when I plug in 0 for x? That's 2 times 1 squared minus 3, which is 2 minus 3, which is negative 1. So 0, negative 1. And then, because the axis of symmetry acts like a mirror, I know I have another point here. So can you see that this is skinnier?
Yes.
Right. Things graph nicely when we're in vertex form. To find the x-intercepts, remember we let y be 0. 0 equals ax squared plus bx plus c. Not all parabolas will have x-intercepts. Remember that. If I had a parabola that opens downward and the vertex is under that x-axis, it doesn't have an x-intercept. All right? It could be above it and open up. That one doesn't have an x-intercept either. So remember, not all parabolas will have x-intercepts. Will they have y-intercepts? Yes, they will always have a y-intercept. They will always have zeros. That is correct. That is correct. So if we're looking at it in general form, standard form, if I have it in ax squared plus bx plus c, the axis of symmetry is found at x equals negative b over 2a. You guys remember that? Probably used it quite often. And if the vertex falls on that axis of symmetry, then to find the vertex, we plug that in, negative b over 2a, we plug that into the function, and we get our y value. If a is greater than 0, there's a minimum at. If a is less than, there's a maximum at. Because if it's positive, it opens up, it has a minimum. This isn't telling me that the minimum is there. We could say the maximum of y equals f of negative b over 2a. Just tell me if the maximum is at that vertex. So identify the vertex and x-intercepts, then sketch the graph. So first thing we're going to find is what? First of all, I'm going to state my A, B, and C. So what's A? Negative 1. What's B? Negative 2. What's C? In my mind, I know that this graph opens what direction? Opens down. Keep that in your mind, that it's going to open down. I can quickly look at it and see that it has a y-intercept where?
3.
At 3. Okay, so those are just quick things I know just by looking at that equation when it's in standard form. I know it's going to open down. I know it's going to have a y-intercept at 3. Which is pretty awesome. If it opens down, then where do you think the vertex is going to be? It's going to be somewhere above it. It's going to be somewhere up here. So x equals negative b over 2a. We have to find that axis of symmetry first. If b is negative 2, what goes on top? 2 times 2 times a, which is 2 over negative 2, which is negative 1. Tell me what you get for the y value. Some students mess up here. Negative 1 squared is what? 1, but there's a negative out in front. So this is a negative 1. Negative 2 times negative 1 is 2 plus 3. So 1 plus 3 is 4. So my vertex is at negative 1, 1, 2, 3, 4, which that's also where my axis of symmetry is. We can mirror that y-intercept. Do we know the shape of this? It's the same as your parent function, right? So that means if I go over 1, down 1, I should go over 2, down 4. So I should have x-intercepts at 1 and negative 3. Let's prove it mathematically. We find our x-intercepts by setting our function equal to 0. How do I factor that? You can do 3 things. You can multiply everything by negative 1. You can factor out a negative 1, or you can take everything over to the other side. What matters is getting that x squared positive. So if I multiply everything by negative 1, then 0 equals x squared plus 2x minus 3. Now this one factors easily. X plus 3, x minus 1. So we get negative 3 and 1, which is what we had by knowing the properties of our parabolas. Questions there? One not done. All right, write the equation in standard form of the equation whose vertex is negative 4, 11 and passes through the point negative 6, 15. So the 3 things we need to plug in to write the equation is we need an a value, we need an h value, we need a k value. The y and the x's will not change when we go to write my equation. So what do we know here? We know h and we know k. H is negative 4, this becomes plus 4 plus 11. How are we going to find A? We know X and we know Y. So we can plug those in. 5 equals A times negative 6 plus 4 squared plus 11.
It's 15. It's 15. You can't see that.
It's 15?
Yeah.
I circled it. Okay, thank you. So 4 equals A times negative 2 squared. So 4 equals 4A, so A equals 1.
Did you say Subtract 11, get 4.
Yep. Questions? All right, a local newspaper has daily production cost of C equals 55,000 minus 108x plus 0.06x squared. How many newspapers should be printed each day to yield a minimum cost? So how am I going to find the minimum here? Because the x squared is positive, it opens upward. So where's the minimum going to be? It's going to be here at your vertex. And the minimum is going to be the y value. So how are we going to do this? Do x equals negative b over 2a. So b is what?
108.
Negative 108, so 108 over 2 times 0.06. What's 108 divided by 0.12? 900. What does x represent? How many newspapers? Do I have to find the y value here? No. The minimum cost is your y value. They ask us how many newspapers. So they need to produce 900 newspapers. If they ask what the minimum cost would be, then what? Then you'll have to plug 900 in and go from there. Questions there?